recording has nothing to do with this. All right, so before we even start, all right, your tangent graph and your cotangent graph are going to be different than your sine and cosine. Okay, the sine and cosine were clearly waves from yesterday, and they went on forever and ever in both directions. Okay, and that made our domain for both of those negative infinity to positive infinity. All right, now what's going to start happening with the tangent and cotangent graph is we're going to have a period, just like we did with our sine and cosine. The period is going to be in between two vertical asymptotes. All right, so just looking at this graph in general, even if I didn't tell you it was tangent, even if we weren't doing trig, I just gave you this graph, you could figure out what the domain is, right? It's going to be, what, every place there's a vertical asymptote, you would skip that in your domain, right? So then, but if this is a period and an equal value, then every one of these are going to be multiples. Every number that's going to be skipped would be a multiple of whatever the period is. All right, so I'm not going to get overly obsessed with the fact that I want you to be able to calculate that domain, but I want you to understand that there are values that are being skipped in the domain for the cotangent and the tangent graphs because of those vertical asymptotes. Okay, now this is a picture of the cotangent graph. Okay, so same thing. We got those vertical asymptotes. All right, so those would be the values that would be skipped in the domain. All right, and then some of you are just going to go, oh, well, it's just flipped. So yes, it's just flipped, but no, not really. Okay. The period for tangent, negative pi over 2, pi over 2. Vertical asymptote there at pi over 2. Okay. Period for cotangent, 0 to pi. All right, so while they look like, oh, you've just flipped them around, yes, the little curvy thing part of the graph is flipped. All right, but the period is different. Okay, does that make sense? All right, so that's just a little pre-part before we actually start taking a look at this and doing some of this. All right, let's go ahead and zoom out and date this and get started here. All right, so today is April 21st. All right, and it's section 6.5, I believe, in the book. Okay, so it's tangent and cotangent graphs. All right, now again, if we want to know what the generic form of these are going to be, like I always give you the base equation with a's and b's. We've done this with our x squareds. We've done it with our x to the thirds. We've done it with all of our graphs. So y equals a tangent bx minus c. All right, for right now, that's all we're going with, okay? And then there's also can be a plus d out here. We're not going to do that right now. Y equals a cotangent bx minus c. All right, now eventually what's going to happen is we are going to do some shifting of these graphs. We're going to shift left to right. We're going to shift up and down just like we have all of our other graphs. So we're going to need some of these values in here to decide how we're going to shift. When we go to shift up and down, there's going to be an extra plus d out here. All right, so just more numbers than what we have dealt with in the past, but there can be a coefficient here. There can be a coefficient in front of x plus or minus a constant. There can also be plus or minus a constant out here as well, okay? All right, now with that being said, what we're going to do, the easiest way I think is just to jump in and do one. All right, again, I'm definitely only going to require a sketch. Okay, we are not going to graph these precisely. We're just going to sketch them. All right, let's suppose I had a y equals a 2 tangent x over 2. So this one has an a. This one also has a b. What's the b? 1/2. All right, doesn't have a C, doesn't have a D, doesn't have anything extra on there. So this is just a really simple one. All right, we're going to do this in phases. We're going to first find our asymptotes. We're going to find what our asymptotes are, and then we will do our sketch. So I'm going to do this in steps. So step 1, we want to find the asymptotes, those vertical asymptotes. All right, now the way we're going to do this, all right, when we looked at that first graph, what did we say? We said the period was negative pi over 2 to pi over 2. Okay, so that has to be memorized for your tangent graph. That's your standard period for a tangent graph that's not been moved away from the zero, not moved away from the origin, rather. So what I'm going to do is I'm going to take that period and I'm going to write a compound inequality. I'm going to go negative pi over 2 is less than, and then whatever is right here is going to go in the center of my compound inequality. So x over 2 is less than pi over 2. And so also let's make a little note for tangent. Always use negative pi over 2 and pi over 2. All right, but we talked about why, okay, because that period on that base tangent graph was not moved away from the origin. All right, now from algebra 2, we're going to cross our fingers and hope you remember how to solve a compound inequality algebraically. I'm trying to solve for x, right? This says x divided by 2. Opposite of dividing by 2 is multiplying by 2. So can I multiply 3 by 2? And you did this in algebra 2. Let me get some head nods. Okay. All right, so I can multiply by 2, crosses out, multiply by 2, crosses out, multiply by 2, crosses out. All right, so I'm solving for x. So we're good there because we've solved compound inequalities before. Okay, instead of having an equation and you doing it to both the left and the right hand side, it's a compound inequality. So I have to do it in all 3 locations to keep it like legit here. Okay, so negative pi over 2, or sorry, negative pi is less than x is less than pi. All right, so that right there is going to tell me where my vertical asymptotes go. All right, so in other words, I have a vertical asymptote here, I have a vertical asymptote here, and every multiple of that, okay, because they're equal distance apart. Okay, so step 2, sketch. Okay, so I generally make a really long x-axis. I try to put my y-axis in the middle. All right, now just depending on what these 2 numbers are will determine how I set my graph up. So obviously this one with being negative pi and pi, I'm going to put 1 on the left-hand side. I'm going to put 1 on the right-hand side. All right, and however, whatever size distance you want. Okay. All right, so let's say that's negative pi. So however distance there, I try to equal it out over here. So there's my pi. All right, now I know there's vertical asymptote there. So I put that on next. I know there's one there. All right, now the distance between here. What's the distance? Because from here to here is pi. So then this whole distance is 2 pi. Okay, so now I got to go 2 pi more. All right, so I'm not going to 2 pi. I'm adding another 2 pi on the end. Okay, so it's about the same distance here, which would put it at 3 pi. So there's my next one. Now I chose to go to the right. I didn't have to choose to go to the right. I could have chose to go to the left, right? Because this is going to what? Create 2 periods of the tangent graph. All right, but I could have done this period and this one over here. So when you do your homework, I don't care. You're just going to do 2 periods. So you can go to the right. You may go to the left. Doesn't matter. Okay. Now for our tangent graph. Okay. In this period, the center, we're going to put a dot. All right, because we know what tangent looks like, right? Tangent is almost like the x to the third graph, right? All right, now what we're going to do is we're going to put the center dot in, because I'm going to have you put 3 dots in for our sketch. So in between here and here, halfway in between, is going to be our next dot, and we're going to go up to the amplitude. My amplitude is, just like it was on sine and cosine, 2. All right, so I don't know, let's say there's 1, there's 2. Okay, so in between here, halfway in between, up to 2, I'm going to put another dot. I know that it needs to look like this. All right, so when I put my dot in this section over here, I'm going to go halfway in between. And I'm going to come down to, again, I'm going to try to make them equally spaced, which is kind of hard sometimes. All right, halfway in between and down to there. So there's my 3 dots. Those are the 3 dots I want you to have on there for your rough sketch. All right, now what do we know about this? We know it's going to hug this asymptote here. Okay, so it's going to hug this asymptote here. It's going to come down and go through those 3, and then it's going to hug this asymptote over here. So rough sketch. Now, what we really don't want to happen, if you get really sloppy on your homework and you get really bad and you distort this because we're just sketching it. I mean, I see some of them that look like literally a straight line going across there. I mean, this is supposed to be a smooth little curve. All right, so just know that when you see it on the computer and you see it in Math Excel, it's going to really look nice. When you hand draw them, they're probably not going to look so nice. All right, I'm going to do the exact same thing for this period. Okay, my period is in between pi and 3 pi. I'm going to go halfway in between, and I'm going to put a dot. All right, I'm going to go to the right. I'm going to go halfway in between there, and then I'm going to go up to my amplitude. So there's a dot. I'm going to come over here to the left. I'm going to go halfway in between this section right here. I'm going to come down to the amplitude. So rough sketch, I got 2 periods. On sine and cosine, for the most part, we did 1 period. On tangent and cotangent, it's really nice to do 2 periods. All right, so was that easy? Kind of relatively easy. Probably the hardest thing would be correctly solving this. All right, but once you solve this, you've got your vertical asymptotes. You know what your period is, and then you choose to go to the right, choose to go to the left. Now, so that we don't have to completely do a whole nother problem here. All right, let's see, am I out of colors? Not completely out of colors. Let's do a blue. How would this have been different had I had a negative in front of that? So I don't have to do the whole entire thing. What does a negative in front of the cubic do? It flips it this way, left to right, right? So I saw Brooklyn do that. All right. So had there been a negative here, I still would have found my vertical asymptotes the same way. I would have put them in the right spot. All right. Except instead of going up on this one, I would have went halfway in between and up here. That dot would have stayed the same. Would have had another dot down here. So it would have looked like this. And no, that doesn't mean it's a cotangent graph, because it's all based on those vertical asymptotes. Okay, so had there been a negative halfway in between, it would have looked like that. That way we didn't have to go through and hire another example. Okay, so I guess what I'm saying is, in Math Excel, don't just base the way the curve is going as to whether you think, oh, this is tangent or oh, this is cotangent. You have to know where those vertical asymptotes are to know which graph it is. Okay. All right, so are we good there? Okay, now let's do another one. Let's say we can go ahead and do it tangent. We could do it cotangent. Depends on how many examples we want to do. Let's sketch. Trying to make it a good one here. Let's do another tangent. Let's do y equals 3 tangent x plus pi over 4. Okay, now I've got a c value in here. My b value is 1. My a value is 3. All right, I'm going to go 2 steps. First step, always find your asymptotes. Okay, so you got to remember your original period, negative pi over 2 to pi over 2. So that's how you build your compound inequality. Negative pi over 2 is less than, I take all of this and I put that in the center of my compound inequality. So then I'm going to have an x plus a pi over 4 is less than pi over 2. These two values always stay the same for tangent. All right, now compound inequality, I got to solve for x. So in other words, I got to do the opposite of what I see in here, which is what? Subtract pi over 4 from every place. Okay, now just make sure that original problem stays first. So when I subtract pi over 4, I'm going to literally write this out and show all the steps. Negative pi over 2. Let's even do it in another color. All right, so minus pi over 4 is less than x, because I know it's going to cross out in the center, is less than pi over 2 goes first, and then I'm going to minus pi over 4. Original problem minus what's in the center. Original problem minus what's in the center. Okay, so common denominators, right? Do this by hand, make this over 4, so this will be negative 2 pi over 4 minus pi over 4. What is that? Negative 3 pi over 4. Less than x, less than x. Okay, again, get common denominators. So 2 pi over 4 minus 1 pi over 4 gives me a pi over 4. So I did show all steps there. Got to get your common denominators because there's fractions there. All right, which tells me what? Then that this is a vertical asymptote and this is a vertical asymptote. Okay, step 2, sketch. All right, again, I'm going to make my x-axis pretty long. I'm going to put my y there in the center. All right, because at this point, I really don't know whether I'm going to go to the left or to the right. Okay, now, are these two values equal distance from the origin? They're not. In my first example, I had, what did I have? I had negative pi and pi, which meant the interval was the same on both sides. This is not the same on both sides. So even though we're sketching it, we still want it to be relatively accurate. All right, so let's just assume, I hate it when it bleeds through the paper. That's annoying. Okay, let's assume that I say 1 hash mark is going to be pi over 4. Okay, because that's my right vertical asymptote. All right, now if 1 hash mark is equal to pi over 4, how many hash marks do I have to have over here to get to this one? I need to have 3 of them, right? So this would be, try to go equal distance. That's going to be negative pi over 4, negative 2 pi over 4, negative 3 pi over 4. All right, now if you want, you can just count hash marks from here to here. 1, 2, 3, 4. So I need 4 hash marks. Watch me do that again. 1, 2, 3, 4. All right, so equal distance. I'm going to go to the right just because I don't have enough room on the left. You could choose to go to the left. It doesn't matter. 1, 2, 3, 4. All right, now, if this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, this would be 5 pi over 4. All I did was count by pi over 4. So I'm hoping the counting part's kind of easy. There's my vertical asymptote. All right, and so clearly the period on these are a little bit wider. Okay, now again, I want to find the center of my first period, which is going to be right there. My amplitude on this one is going to be 3. Again, clearly not drawn but to scale here. -3. All right, so halfway in between, it's tangent. Nothing is being flipped, so dot up here. Halfway between on the left, down to the amplitude. And again, I've got to hug here. Swipe through there and then hug down here. Duplicate again in a second period. Center, half up to 3. Half down to -3. And since we are just doing rough sketches, sometimes they're going to look kind of bad. Now, how's a cotangent graph going to be different than, there will be one thing that's going to be different if this was cotangent. My original period. Brooklyn, what were you going to say? You were doing this. Yeah, these spaces are going to be, these vertical asymptotes are going to be at a different spot, right? When we looked at that at the very beginning, when we looked at the cotangent graphs, the period was what? Between 0 and pi. So these two values change when I go to calculate where my vertical asymptotes are on cotangent. Okay, so let's do a cotangent. Okay. And it really doesn't matter here. Let's do this one. Let's say it says sketch. Maybe say y equals 2 cotangent pi over 2x. All right, and then maybe they'll have a set of parentheses around that. Maybe they won't. Okay, so that could be optional. Maybe those parentheses will be there. Maybe they won't. Just depends on how the book writes it up. Okay, so we're still doing 2 steps. All right, so our first step is still going to be find those asymptotes. All right, but because cotangent has a period of 0 to pi, those are the values I'm going to use. So let's write the same sentence here since this is our first cotangent. For cotangent, always use 0 and pi. Because on that base cotangent graph, our vertical asymptotes, our period was between 0 and pi. All right, so again, I'm going to go make that compound inequality. I'm going to have 0 is less than. All right, and then whatever is right here goes in the center of your compound inequality. So pi over 2, x is less than pi. You've got a compound inequality. You're going to solve for x. Can we shortcut that and multiply through by the reciprocal? Okay, so I can multiply through by 2 over pi. We know, though, that whatever's in the center is going to cross out. I'm going to have an x. So I'm going to multiply this by 2 over pi. I'm going to multiply this by 2 over pi. Okay, so 0 times anything is 0. So that left-hand side didn't change. I've got an x in the center. If I take pi times 2 over pi, pi's cross out. I just have 2. All right, so this is nice. These vertical asymptotes are on our integers. Okay, so again, this right here is going to provide you with your asymptote. So that's going to be a vertical asymptote. That's going to be a vertical asymptote. Okay, step 2. We're going to do our sketch. Okay, so I'm going to make a great big long x-axis. I'm going to put that y-axis in the center. All right, now 0 and 2. 0 is right here. 0 is the y-axis, isn't it? All right, and then I don't care how far. There'd be 1, there would maybe be 2. So I've got a vertical asymptote at 2. All right, and then I absolutely hate it when the vertical asymptote is on that x-axis or the y-axis because it's hard to see. So generally what I do is I do it right next to it because we need to be able to see that. Because if you forget that the y-axis is a asymptote, then it's going to create a problem. Okay, now on this one, This one's easy, right? Again, I don't care which direction you go when you do your homework. If I want to make another period over here, I could. But I could easily make another period to the left as well. Doesn't make any difference. I need a period of 2. So if I chose to go to the left, let's try to make that equal distance there, then I would have one here, vertical asymptote there at -2. But again, otherwise I would have had one at 4. So it doesn't matter which way I go. All right, we always go in the center. So let's do that first period from 0 to 2. We go to the center. All right, this is cotangent, right? So my amplitude is 2. So trying to somewhat keep these equally spaced. So it's got to go the opposite way. So I'm going to go halfway in between, and I'm going to go up to 2. I'm going to go to the right-hand side, halfway in between, down to -2, because I need it being swooped the other way here. So we're going to hug our asymptote, come down through those. All right, and then see I missed. So when you miss, you make your dot bigger. There we go. It's a sketch. I'll let you do that. We're not trying to be precise here. Okay, same thing over here. All right, halfway in between. I want it to swoop this way. So on the left-hand side, up to 2. Right-hand side, down to -2. Hug, go through the dots, hug down there. Again, a negative here would have what? Made it flip, but that would not have turned it into a tangent. It just would have been a reflected cotangent. So I don't think they're hard. Okay, now in calculus, are we ever going to do this type of graphing? No. I thought since we're going through the trig that the little sketches here would be a good idea to get used to it. All right, in calculus somewhere, we will probably deal more with sine and cosine. All right, we're going to do things in calculus next year, like find the area between 2 curves. Well, they might ask you to find the area between a sine curve and a cosine curve. All right, so then if you put one on top of the other, you're going to have a space area in between. So you need to be able to do a rough sketch of them to be able to find that area that's in between the 2 curves. All right, so that's the whole point of the curve sketching thing. But we can't leave tangent and cotangent out. We are going to shift these left to right. We're going to shift them up or down. Okay, we can do that with sine and cosine. We can do it with tangent and cotangent. All right, we're also going to possibly, I don't know if I'm going to do it this year or not, we could sketch the cosecant and secant graphs as well. Okay, we may do that just a little bit. Okay, so we got quite a little bit of sketching here, and then we'll get into some other stuff. Actually, after we get done with all of our graphs, then we may do our project. We may do a project, a graphing project. All right, so questions. Are we good? This kind of easy. About the only math you got to do is solving that compound inequality right there. So the math's not hard. All right. It's about 8:30, so you got longer than normal to work on the homework assignment. I'm going to stop sharing here for a minute. All right. Are both you two at home good? All right. We'll see you tomorrow then.